So good evening. The Montgomery Amateur Radio Club here in Maryland is proud to present David W2LNX, who will talk to us about building the Hardrock-500 Amplifier. David is chairman of our club's education committee and has done an outstanding job training new hams. His special focus is working with young people to spark their interest in science and technology, as well as help them get their amateur radio license. We are very proud of David. David is a retired software engineer and adjunct professor. He has been a licensed ham for 45 years and enjoys experimenting with HF and VHF, UHF digital modes. So welcome, David, and thanks for taking the time to be with us. And now it's over to you.
Okay, so let me do a screen share. And what I'm going to be doing is sharing the whole desktop, and I have everything prearranged. So press home. Oops. No, we don't want to start at the end. We want to start at the beginning. There we go. So, that was a thank you for the introduction. So I'll go on to the second slide. So, more than a year ago, Chris and I are good buddies, and he's my digital modes Elmer, and he puts me up to all kinds of ham radio mischief. It's like, why don't you do that? Why don't you do this? So, but also I wanted to celebrate my new eyes. I had cataract surgery and I can see again. It's no fun soldering when you can't see what you're soldering, you do it by feel, no fun. So he suggested I assemble a QRO Go kit. So what's that? Oh yes. The 500, there's a 500 watt RF amplifier I could build. So, oh yeah, I've been hearing about that. So, so I said, okay, get that. And also big batteries, lithium ferrophosphate batteries, but that's for another story. And I thought I'd be using the RF amplifier for 150 watts, because in 2001, you can still use 150 watts PEP. And at digital modes at 150 watts is 100% PEP. I mean, it's not sideband, and also for Winling. So I went to the website, and by the way, all these links are live links. I'm not going to do that. I'm going to post the presentation in several days. But anyway, these are all live links. And for the brevity of time, I'm not going to click on every link. So I purchased the 500. So finally, it all came out. Thank you, Jim. The Hardrock-500 Power Amplifier Support Kit. And he had worked a deal with a separate company, I think it's called RF Power Tools, to supply the amplifier board. Because the idea with the support kit is you buy this third-party amplifier board, you build that, and then you install it into the essentially a bare bones amplifier without the amplifier case. You install the board into that, and also he has a automatic antenna tuner, the ATU. And I'm constructively lazy, so I ordered pre-wound toroid coils. As it turns out, there aren't that many turns on those coils. And when I buy something, the first thing I do is download the manuals and read them through and say, oh yeah, because it reflects the quality of the product. If the manuals are shabby, then it kind of puts a dim light on the whole idea. So tools that I purchased. Well, I saw that I needed to solder two semi-micro VRF 2933 MOSFETs, and they have these tabs, and I needed high temperature. I also decided to use lead-free solder, and I learned that it needs to run at 385C, which is a little somewhat higher than lead. And so this hand means show the photos. So I'm going to minimize that, and let me go to the photos, which is right here and there. Now, soldering tools. So this is my workbench. I'm not exactly a neat freak, but I'd like to be able to find things. My rule is if nothing is relevant to a project on the table, it goes off the table. It could go on the floor or on another table, but I can't stand having it on the table. So I bought a Weller. This is a very handy, a Weller soldering station just for the project because I wanted to have the heat. And this is a very handy circuit board holder from Panavice. And this is Jim's manual over here, the construction manual. You know what? And let me zoom in. There. Could go full screen there. So this is what it looks like. Beautifully done. And it was good reading. And my Elmer N4DR Mark, who's for construction of kits, he said, you got to read the manual until it's really clear in your head. Because, what is he? Measure twice, cut once. So here it is. This is a stock photo off Amazon. So the various tips for small components, I would use this tip. But when I needed it, I would for the tabs for that MOSFET, I had this big tip, which is wow. So it's not quite it's 0.7 centimeters, 7 millimeters. It's quite wide. And that did the trick. I mean, in fact, it made it very easy. In fact, made it very easy to unsolder one of the MOSFETs. More about that later. Anyway, so here's the Panavice. So, decades ago, I bought the base and every single attachment. And my version doesn't have this, but that's okay. But it has this. And lead-free solder. And Chris recommended that I get this what is it, SAC 305 solder. There it is. This is the same thing except thinner solders. SAC 305. I don't know what that stands for. And liquid magic. This is liquid the flux, and especially with the small components or actually the small through holes pads, the pads of the small through holes. This was very useful, very helpful. The other thing is sometimes you need to manipulate parts, and Chris suggested, get tweezers with ceramic tips so you don't lose heat manipulating the wires or the components. So, oh boy, that's brilliant. And this is another very useful. This is a flat nose pliers or a duck-billed plier, and it's very useful for tightening screws or flattening wires. It's certainly not a replacement for needle nose pliers, but these are definitely not needle nose. And the Craftsman brand is still around, and you can buy Craftsman tools at Home Depot, but the original company, Sears, I think, is out of business or completely out of business. But they were smart. They sold the brand. I happen to have thermal compound. Jim provided it in his kit. I'm remiss. We have let me. But when I reach the end of this, I'll Jim, I forgot to introduce you. Yeah. So this is, without this, I discovered this thread locker when my son had a laptop computer and Dell, and all the screws fell out of the bottom. So I had to buy the screws, and I said, aha, Loctite or thread locker, same thing. And the blue stuff, so it's semi-permanent, very useful. So for the little screws for assembling it, I use this. This is a useful tool. I was curious to see how much current does the amplifier draw when you go at 500 watts, various wattages. It's about 8 amperes. I discovered there's not much variation in the amount of AC current that's drawn. And in a separate conversation, Jim explained to me why. And how was I able to measure the current through an AC line? Well, you buy an AC splitter, line splitter, and what you do is you clamp that over that. Now, for a little bit more money, I can also do it for DC power. So if you're discharging 100 amperes out of a lithium ferrophosphate battery, or no more than 100 amperes. You can actually measure how much current they're discharging. So that's kind of useful. So we're finished with this. Anyway, I forgot to introduce Jim, and let me go back to here. So let me scroll back. Well, actually, I have your name at the bottom. Anyway, so, Jim, without you, this wouldn't have been possible. So Jim is the founder of Hobby PCB, and he works with 2 other fellows. Jim is the engineer who designs these amazing products. I first got introduced to your stuff with the Hardrock-50, which is a 50-watt amplifier. I couldn't see well enough to build it, so I bought 2 of them, and I had Mark build 2 and keep one. It's a pretty good deal for him and for me. But anyway, so and you've been around for a long time. I think, oh my goodness, maybe, I don't know if it's 10 years, but you do a great job. So compliments to you. And as I said, I have the links on. So if I have any questions, if people have any questions, you can ask Jim a question or 2. And if not, he'll say something about the company. Okay, so back to where I was. So bear with me. Okay. Now, so we're photos. Okay. So unboxing. So what does it look like? Let me get rid of this. Maximize. So of course, apparently it's a thing among geeks, the unboxing of a product. Wow, there's YouTube videos. Must be 1,000, no, more like 1 million YouTube videos of unboxing a product. So, and I had the foresight to take photos of my build because I did intend to share this. So this is what it looks like when you open the box, and all laid out, all the modules. This is an add-on product, the ATU. So I put a little label just for consistency. Let's see, okay. And this is a photograph of one of the 3, I think 19 volt, 18 volt, or 19 volt power supplies connected in, which are connected in series to form a 56 volt voltage for the MOSFETs. And then there's 3 little fans in this box too. That's to cool the actually the amplifier board. This is the order form I had mentioned before for the toroids. And this is what it looks like all around. And I said, oh, there's 5 turns on each. Well, I could have done that. Actually, I'm being a little cheeky. The wire is pretty stiff. It's not like number 22 gauge wire that you're winding on a toroid, a little toroid. And this is the, sorry for this bad picture of the, this is called the AN 1819 evaluation board for that, for the that MOSFET. And this is where the MOSFETs get mounted. Now, it'll be clearer pictures later on. And more parts. And this is everything ready to go. So it's very clever what Jim did is these are like, there's 4 panels and 2 of them are stacked together, are stacked on top of each other. So the 2 halves will come together to form the case. Brilliantly done. And this is the panels, carefully wrapped so they don't get scratched. A bottom panel, a top panel, and of course the 2 ends. So we're finished with that. And go back to photos. And then building the low pass filter. Okay, maximize. So the low pass filter is semi-built. I guess it's the surface mount components already installed. These are the 3-hole components, and those toroids which I had purchased, were installed here. And here, that's what they look like. So you actually have to be very careful to put the right toroid in the right hole. So check twice, solder once. Actually, you can solder twice as long as you don't snip it, you know, with a flush tool, a flush cutting tool. So this is what the filter looks like mounted on one of the inside panels. These are like standoffs. This is going to be the standoffs for the actual amplifier board. And this is the two half sides installed over here. Yeah, I couldn't figure out how to make a bigger mouse, so hopefully people can see that. Oh, white on black, that should work. So that's that assembly. Then let me go to this. So there's not much here. So if you lay this out, this is what it looks like. 3 power supplies, the power supply control board, and also an interface to the transceiver. This is the PTT, one of the PTTs. This is rig control. And you can actually look at the front panel through a USB port. Very nice. And so this is how it is wired. And Jim provided a video of how to actually lay out the wires. That was very useful. So I followed the videos, but I followed along. So that worked out pretty well. And here we are. Oh, here it is. This is what, so this is the other half, the 2 halves. And later on, the 2 halves will mate together. And here we are. So that's done. Now, so this is the rear panel. The 3 little fans will be installed on this, and then it's going to be installed on the rear panel. And this is with the fans installed. And right now it's designed, it's wired up so that there's no ATU, no automatic antenna unit. So it's jumpered out. The RF goes in and goes back out again. That's where the ATU goes. And this is what it looks like that's mounted on the rear panel. This is the board with 3 fans and the big fan. And a standard, oh, I forgot there's names for everything, but the standard receptacle for the universal connector. And in fact, in the instruction says, whatever country you're in, you have to buy the power cord, so it fits this. And the power supplies accept 120 through 240. So that works out pretty well. This is the same panel, but from the outside. And also on the board, that this are the SO239 connectors, the 3 of them. I thought that was brilliant. That was absolutely clever. And there's little offsets inside, so there's a little space in there. Oh, good old trusty grounding lug. Can't forget that. So we're finished with that. And moving right along, front panel assembly. So you got to admire this stuff before you have to eyeball this stuff, really understand which way is which. And you really have to understand which is the front, which is the front and which is the back. So this is a touch screen, TFT, what is it, LCD color, LCD 2.8-inch touch screen. There's 2 of these. And then we have a Arduino Mega 2560. And this is the board where everything gets mounted on. And you have to look at it on reverse. Same boards, flipped over. This is the screens. Oh, I made one construction mistake. I forgot to remove the green tabs. So I don't know whether that's a feature or a mistake on my part. So here it is. And the task was, let me go back one, is to solder header sockets, header pins, so that the AT Mega can just plug right into it. So here it is. And this is the other side. And this is the front panel, the whole panel mounted on. And this is the other side. So I do have a question for Jim at the end. And the question is, and I'm going to state it now, so make a note of that. How long does it, someone who's built like 10 of these in a row, how long does it take them to assemble it? Because it took me a while because I was working very carefully. Anyway, so that's the front panel assembly. And then moving on to the ATU. Let me close this. It's mostly assembled, it's just a matter of putting on the coils. So there are the coils. That's it. As I said, I saved a lot of time not having to wind coils. I think it's 14 gauge or 16 gauge wide. It's pretty stiff. And now the main event, which is the amplifier board. So this is a heat spreader, and the amplifier gets mounted to that in such a way that the MOSFETs will touch these with the gunk on them, namely the heat conductive paste. And this hole is for a temperature sensor. Okay, and this is, so one of the things I realized, you need to fit everything. Just lay things out, no soldering, no tools, just lay it out, see what it looks like. So this is the board. This is an evaluation board. The reason why it's called an AN 1819, it's the name of the application note from Semi-Micro, and they have a reference design and a reference schematic. And by the way, Semi-Micro has been purchased by Microchip, my favorite microcontroller company. I think they're the only one at this point. Oh, I shouldn't say that too loudly. Antitrust people. And so I looked at the side view and I said, ooh. So I'm glad I found construction, very small error, and reported to Jim. So Jim immediately updated the manual. There's a clearance in here. And as luck would have it, when you remove one washer, it fits perfectly. So the thickness of these Teflon washers and the metal part of the MOSFET are the same thickness, so that worked out really well. And then here it is again. And here are the two coils. This is the famous coil T2. This is a binocular coil, and there's another binocular coil. Is that binocular? Yeah, I think so. This is one core, and I think there's two pieces in here. Oh, I also needed, I think, to solder this. This is a big electrolytic capacitor. As I said, all the surface mounts are done for you. So there it is. I'm starting to put on the semiconductive paste. I made a mess, and I said, what's the big deal? It's going to be covered up anyway. So. And on the flip side of the board are two temperature sensors. They do different things. Now I have to look at the instructions. The instructions explain what they are. Anyway, so here it is, and that will match up with the hole. This goes into that hole that you saw the paste in the previous. Here it is. That matches up with that. And the instructions say very carefully, are you sure you got the orientation right? Are you sure you got the orientation right? Are you really sure you got the orientation right? Yeah, I was sure, so I went ahead. I keep forgetting to do that. Okay. And so this is already mounted. And this is soldered on with my fat tip. And I'm glad I listened to the suggestion to lift up the tabs. I think one of the MOSFETs I blew up. And we'll talk about that shortly. Okay, more photos. So final assembly. Maximize. So this is where everything comes together. So these are the two halves, the two half cases. And this will get flipped over and placed over that, over this case. And there, this is what it looks like, assembled. And here we're going to put parts here. More parts. So that's the filter board. Oh, let me see. No, that's the same view turned around. Oh, I know what this view is. I had these. Okay, I got a little disoriented here. So what this shows that the back panel is installed. The back panel is not yet installed. That's what that shows. There, that's so the case is not complete. Now finished construction. This is what it looks like top view. I'm going to install 2 more boards. The amplifier board, and oh, I don't have a picture of the fins, but there is this big heat sink underneath the heat spreader board. Oh, phooey, forgot a photo. Oh well, next time. And there is a sheet, heat conductive plastic, which you screw it's pretty heavy actually. It's about 2 pounds of copper to the heat sink, forming a sandwich with that heat conductive plastic. It got a little wrinkled in shipping, but I think it didn't hurt the amplifier. And I'm starting to connect cables here. So this is all ready to go. And if you look carefully here, this is actually a working amplifier. But what I did, the next step was to remove this jumper, the automatic antenna tuner jumper, and proceeded to install the ATU. There it is. And so there's a couple of coax cables going to right over here, connecting these two. And here it is. There's another, this is the bottom view, power supply. So the fan blows through the power supply, and the little fans, where are they? I can't see them here, but the little fans, which is temperature controlled, the speed is temperature controlled, blows through the assembly. Oh, I see. The fans are right there. They're underneath. You can't really see it, but there they are. Okay. So this is the case put on and rubber feet. So you know it's the bottom. And I turned it on and it lit up. I said, wow, I didn't let the smoke out. But also I got worried. Okay, it works. What bug don't I see? Because if it doesn't work, we have something to fix. But you know, if it works, does it work correctly, or it just seems to be working? So, you know, it's the first question, you know. When you build enough of these things, you worry a lot. And so it's time to set the bias on the MOSFETs, the power up MOSFETs. And this is a stock photo from the Hobby PCB website. It's a prettier picture than what I have. And here, another pretty picture in the back. So here it is, USB, transceiver, RIC control. You can set the band and of course do PTT, or you can use an RCA cable, phono jack, phono plug cable. And you can also do a similar function with this in terms of RIC control and band control. So that's that. And so what comes next? Well, so let me go back to the, there we go, testing. So this is where the fun started. Now, Jim has a very generous guarantee policy. You build something doesn't work, I will fix it for free. And also Jim is in Baltimore, which is handy. So I was testing it with an IC 7300, and the 7300 is very nice because you can adjust the RF power from 200 milliwatts, basically zero, down to 0%. And I was curious, what does 0% power look like? And actually, there's a little bit of RF all the way up to 100 watts. So I found I would set the power level to 5 and then adjust the audio drive, the upper sideband audio drive, using the digital modes programs. These two programs, WSJT-X and running FT8 mode, and FLDigi have basically volume control for the output. And I got dangerous. Bought a commercial grade Bird 1 kilowatt dummy load, my favorite tool, space heater. And so there is software that you can get, Windows software, which actually I run on my Linux desktop because it works very well with Wine. Wine, it stands for, Wine is not an emulator, but this is a program that's been around, over a decade for sure. And I was testing, and I had made several wrong assumptions. I'll reveal them at the end. And so I was doing a lot of testing and, saying, well, if this is a USB 500 watt amplifier, well, I'll derate it. I'll derate my RF. And since I was planning to use it for field day, FT8, I would do various power levels, keeping an eye on the remote panel display of the temperature. And I did this for a while, and then I turned it off, and I came back like a week or two later, and it's like, oh, the thing keeps shutting itself off. What's going on here? So I found out that I had destroyed one of the MOSFETs, and it was very easy to tell. The drain was shorted to the gate. Oops. So I sent an email to Jim, so what do I do? He says, well, look, you got to get a part. So he's recommended Octopart. That's the Google search of electronic parts, essentially. And they go through all the websites, DigiKey, Mouser, Newark, everybody. I think Farnell also. And I found the very last part, one part. And I didn't want to buy a pair, I just wanted to buy one. And I guess the demo demons were really smiling on me. I said, okay, you messed up, fine. We'll let it go, just order the part. So $150 later, I have a part in hand. Now, it turns out the part blew up because I had cracked the T2 toroid coil so yeah, there's something called thermal inertia. Things don't cool as fast as is indicated by a temperature sensor, which is not attached to the toroid core. So I cracked the toroid core. And so Jim replaced it with a better toroid with a pair of them side by side. And so now, since I had intended to use it for digital modes, I wanted to really cooling, move as much air as I can through it. So anyway, let me show you the testing photos. So here we go. This is my setup. There's the amplifier. And what worked out was two 14 centimeter fans on top. This is the 7300. This is happened to be running no, this is WinLink. But this is the setup, and there's my little space heater there. It actually got warm. I was surprised. Just warm. Two views of this. Used, of course. And side view. Pretty heavy, 28 pounds. This is a screenshot actually on my Linux desktop of this program, and I happened to capture when I was talking, running audio through it, and it, you know, as rated for the 5-watt input. And I happened to catch a screenshot of it jumping up to 500 watts peak. And here it shows that the ATU is bypassed. This is into the dummy load when I was doing this test. So I got a nice picture. So proof by a screenshot. And this is a stock photo of an RCA phono cable. So it's connected to the back of the 7300 to the amplifier. I had sent Jim an email. Do I need to have an amplifier, keying amplifier relay? He says, no, not necessary. With modern radios and modern solid state amplifiers, it's not necessary. It's for the tube amplifiers, you need something like that. Okay, so thank you for that. This is a homebrew KX2 rig control cable. So this is a tip ring sleeve adapter. This is an old video adapter from composite video from, I think, from last century. And this is just a simple, also from the last century, they had sound, you know, the soundboards that had these RCA connectors, or is it the other way around? But I have a pile of these. So by doping out, looking at the documentation, the Hardrock-500, and also for the KX2, and using a continuity tester, this is the combination that works. So it was really kind of cool that you change the frequency on this KX2 and it changes the frequency on the Hardrock-500. That's kind of cool. And this is also for an FT991A for Yaesu. And I took a photo of that. And easy to build these things. I have the parts for them, but I was lazy, so I went ahead and ordered it. But I know I didn't make this. Why would I put on 3 tie wraps, huh? So it wasn't me. So this is what it looks like. This is my souvenir. This is a damaged MOSFET. What's it called? It's called the VRF 2933. There we go. And see, Jim sent me this photo. You cracked it. So my, yeah. So here is the same. This is the board, the RF board, the amplifier board with the heavy duty cores and a pair of them. And so cooling. So Jim suggested, you know, get some faster coils and make sure it don't exceed the 2 amps. So I did that. And of course, when I connected directly to 12 volts, it wasn't speed controlled. And my goodness, this sounds like, I don't know, one of the older planes. It sounds like a 727 taking off. So, okay, it helped some. And so I said, no, I don't want to use those fans. So what I wanted to do is use fans on top. So I removed the top, got some hardware cloth. This is a 1/4-inch spacing, and attached it to that. I wanted to keep the RF in, you know, so that's why you need to have that. And this is a close-up view of the amplifier board. And so I got from my junk box, my junk pile, I should more say, from fans from computers. And that sounded like a 737 taking off. It was just too noisy. I said, I can't live with that. So I said, okay, let me do a little research. So I found these are actually 120 centimeter fans, but way too noisy. So I found these, and the decibel rating was very attractive, and even has a speed control switch, fast and slow. But even with the fast switch, it's the noise is quite tolerable. And of course, I want to keep the air where it belongs, so I used the black gaffer's tape until it worked out. And so we're done with that. So am I done with, so where am I? Yeah. So operating. Well, it works well with these 3 radios. Also, Jim has an IQ32, which I also have. And that was, I use it for initial testing because you can easily change the amount of power. And so apologies for not putting that on the visual. I'm going to, when I release the visuals, I will put that in. And I never ended up using it for WinLink because within 500 miles, 50 watts is plenty on 40 meters, 80 meters, sometimes 20 meters. But voice on an 80 meters sideband net, monthly hospital net, let me tell you, you really need the 500 watts. And so I said, okay, I've justified building it. But I didn't build it to use it. I built it to have fun building it. Well, that's not true. It's also to use. So bypass mode, when the amplifier is off, it connects the antenna 1 coax connector right through. So I asked Jim, how much power can I run through the amplifier when it's turned off? He said, 1 kilowatt. Well, I'm not going to do that because the radios are so-called barefoot, which means the maximum of 100 watts these days. So anyway, so this is attributed to Albert Einstein, a person who never makes a mistake, never tried anything new. Okay. And lessons learned. Read the assembly manuals before purchasing the kit. And that's, well, in this case, this is purchasing a construction kit, but this is true of any product. There are lots of products I would download the manuals and it's like, PU, I'm not going to buy this. And work slowly and understand the assembly instructions before building. You really get, it's got to be clear in your head. And even then you make mistakes. So this is what I learned a little bit the hard way, but it was worth the lesson. So I learned something. So Jim said, this is designed to be a single sideband RF amplifier, really. And so the duty cycle of single sideband, which is about 20%. Oh, typo here. Oh, no, it's not, that's not a typo. This duty cycle of single sideband, and I looked it up, is about 20-25%. Does not equal 20% of key down digital modes duty cycle, because that was one of my assumptions. So the visual is correct. I got that right. And also, you can't, apples and oranges, single sideband, peak envelope power does not equate to digital modes peak envelope power. Well, I knew that. It's, you know, when you do like FT8, it's 100%, or PSK is 100%. So I knew that, you know. Anyway, so kit building is satisfying, an enormous amount of fun. But I have to say, this experience was more like an adventure than a just building a kit. And so, so these folks I already had credited, and I think I'm done. So questions, you can send email to me, and I plan to post the, I think there's one mistake in the visuals. I'll fix that. And also I'm going to add in a long list of links to the various things, and as a resource page, because people always ask for that. Okay, so I'm done. So I have to exit share, and then I'll maximize that. So I'm going to mute.
Okay, thank you, David. Do you want to introduce Jim?
Oh, yeah. So Jim, yeah, you don't have a camera, but you have a mellifluous voice. So you could, so Jim, so you can pin Jim, but or spotlight him, but that's okay.
Yeah. If I talk, it'll throw up at least my name up there.
Oh, okay. That's right. I forgot about the Vox feature. Yeah.
Yeah. Well, David, thank you for that wonderful presentation. And yeah, I would say that what we've discovered is that a power amplifier is most efficient at its maximum output because it basically dissipates the same amount of internal power, no matter how much power it's putting out. So running it at 100 watts it uses it gets just as hot as if you run it at 500 watts, because the additional power it takes is actually putting out. Our design goal was to make a very lightweight amplifier, primarily for traveling. That amplifier with the ATU is about 18 pounds. So you can pack everything, an antenna and a radio and the amplifier in a suitcase that doesn't need extra luggage on the airline. It's sort of, the FCC doesn't allow you to make an amplifier that is 5 watts in, 500 watts out, which is why we make it in 2 different pieces. You're allowed to build whatever you want, but you just can't sell it. And that dates back to the days of CB, when they didn't want ham radio amplifiers to be used by CBers to take the 5-watt CB radio and amplify them to 1500 watts. So that's kind of I don't think they're concerned about that anymore, but rules never change. And David kind of showed it with the fans. The amplifier actually makes 12 volts output at about 3 amps. So you can actually power a QRP radio directly from the amplifier. So you don't need to bring another power supply for the radio. A single cable over to, a KX3 or a IC705, and the amplifier is up and ready to go. And we do have interface kits for Zygu radios, Elecraft radios. The IC705, it needs a special interface because it only talks over Bluetooth, but we have that one too. Lots of Yaesu FT817. It seems like almost every week a manufacturer is bringing out a new QRP radio, so it's great fun. And I use mine every Saturday morning on 80 meters on the sked on single sideband, and I didn't have to do any extra cooling or anything. It keeps it nice and cool. Now, if you want, I guess the full-time digital mode, it might need some extra fans. That's what we've learned. So, if anybody has any questions, I'd be happy to answer them.
I think Hank has his hand up. Oh, and welcome, Jim. Thank you for joining us tonight.
Yeah.
All right, Hank.
Yeah, I do have questions for David. And I guess the first one is, and I may have missed this at the beginning of the presentation because I had a phone call I had to take, is the Hardrock-500 ATU part of the package for the amplifier, whereas the ATU 1819 you have to buy separately?
Yeah, so actually it's 3 parts. So 2 of the parts, the amplifier support kit and the ATU, are sold by Hobby PCB. And then they have a deal with another company called RF Power Tools. They probably buy it wholesale or they buy a lot of them. So there's another company called RF Power Tools that makes the AN 1819 evaluation board based on the semi-micro AN 1819 application note. So those 2 put together, if you buy the 3 parts, you can build a ham legal amplifier because you build it.
Okay, so you do need all 3 parts. The ATU does not come with the basic support unit.
Well, you can run the amplifier without an antenna.
Well, that's true, but it was just not clear on the website initially, but when I looked at some of the listings under all parts, it's quite clear that you have 2 parts that are necessary accessories if you want the full process. The second question I had to deal with Octo part. It looks like you can submit a bill of materials and they'll fill the order or tell you what they have or they don't have. I'm not certain how that works. And I thought since you might have used it, you might be able to fill us in on that.
Well, Octo Parts was, Jim had suggested that to search, instead of going through all the electronic parts vendors manually, he pointed out a search engine website, Octoparts, and they do that for you. And
they do that for free?
Yeah.
Well, that's
it's kind of like yeah, it is. I think 8 Books does the same thing. They go, you look for a book and they come up with a like 20, 30 bookstores, used books, that is.
Yeah.
What do you call it? The cheap flights, or all these, booking agents for flight. I haven't flown recently, so I haven't used one. Cheap flights is one of them. And what they do is they search all, American Airlines and what else? TWA, Pan Am. No, not Pan Am. Good name for an airline, but gone. Yeah. And
All right.
that's all I'm sure they have more capability than just being a search engine. It was, in fact, I don't know if I mentioned it, it was the last part in the country. And the last single part. Nobody was buying that one part. They wanted to buy a pair, and there were no pairs. And so I said, I did mention that.
So it's someplace on those container ships offshore. So anyway, thanks, Dave.
Yeah.
Okay, any more questions for Dave or for Jim? Well, all right. It's a great presentation. Want to thank Jim for joining us tonight, and great products you saw, amazing. And thank you, David, for taking the time to join us tonight and for your terrific presentation. Hank, did you have one more question? Hank, you're on mute.
Yeah, I'm on a tablet, so it takes me a while to get the keyboard to come up. No, I had no other questions. I was clapping hands as if that's
okay.
what showed up. I don't know if that's anywhere.
All right. Okay. All right. So I want to thank all our viewers who joined us tonight. And if you want to learn more about our club and our activities, you can find us on the web at marcclub.org. And thanks for joining us, and 73 to all.